Have you ever wondered why your Linux system runs smoothly, even when you have multiple applications running simultaneously? It all boils down to effective CPU management. This fascinating field includes optimizing CPU usage, scheduling tasks efficiently, and monitoring performance. We'll be exploring intriguing concepts like CPU scheduling, process management, thermal and power management, and even delve into areas like CPU affinity and partitioning. So, without further ado, let's delve into the world of CPU management in Linux. A crucial part of CPU management in Linux revolves around CPU scheduling and process management. At the heart of this is the Linux scheduler, which judiciously allocates CPU resources among multiple running processes. The default scheduler in Linux is the Completely Fair Scheduler, or CFS. As its name suggests, the CFS works to ensure that each process gets a fair share of the CPU's time. Now let's dive a bit deeper into CPU scheduling policies and priorities. These can be broadly categorized into real-time, normal, and batch. Real-time scheduling is for tasks that require immediate attention, normal scheduling is for regular tasks, and batch scheduling is for tasks that can wait. How these policies affect process execution is a fascinating topic in itself. Monitoring CPU scheduling behavior is also a critical aspect of CPU management. Tools like TOP, HTOP, and PS can give you a real-time view of what's happening in your system. These tools can show you which processes are running, how much CPU each process is using, and other resource consumption details. Process management commands such as PS, TOP, and HTOP are your friends when it comes to viewing running processes and CPU utilization. These commands can provide you with a wealth of information about your system's health and performance. Let's not forget about the NICE and RENICE commands, which are used to adjust process priorities. These commands can help you prioritize critical processes or even deprioritize less critical ones, thus giving you more control over CPU scheduling. Remember, effective process management can optimize your CPU usage and improve system performance. By understanding and leveraging these concepts and tools, you can ensure that your Linux system runs smoothly, efficiently, and effectively. So go ahead, take control of your CPU and let Linux's powerful scheduling and process management features work for you. Another key aspect of CPU management on Linux is CPU affinity and thermal and power management. CPU affinity is a scheduler property that binds or unbinds specific processes to certain cores of the CPU. This can be quite advantageous as it can significantly enhance performance by minimizing cache misses and improving locality. Tools like TaskSet allow you to manually set CPU affinity for processes, or you can configure CPU affinity in task scheduler settings. Now let's talk about thermal and power management. It's crucial to keep an eye on your CPU temperature and power usage to avoid overheating and to optimize power consumption. You can use tools like sensors or hardware-specific utilities for this purpose. There's also an option to adjust CPU frequency scaling settings, balancing performance and power consumption dynamically. Understanding and managing CPU affinity and thermal aspects can give you a significant performance boost and prevent potential system damage. Now that we've explored the various facets of CPU management in Linux, it's time to summarize what we've learned. In our journey through the world of CPU management in Linux, we have touched upon several key areas. First and foremost, we discussed CPU scheduling and process management. We learned how Linux uses a scheduler to manage CPU resources among multiple running processes, and how understanding CPU scheduling policies and priorities can affect process execution. We also looked at how to use process management commands to view running processes, CPU utilization, and resource consumption, and how to prioritize these processes using NICE and RENICE commands. Next, we delved into CPU affinity, which allows you to bind specific processes or threads to particular CPU cores, thereby improving performance. We also learned how to monitor CPU temperature and power usage to prevent overheating and optimize power consumption. We then explored the concept of task scheduler configuration and how to adjust scheduler settings to optimize CPU utilization based on workload characteristics. Moreover, we also touched upon the importance of CPU performance monitoring, understanding NUMA architecture, kernel tuning, CPU isolation and partitioning, and finally, setting up monitoring and alerting mechanisms. Each of these aspects plays a vital role in optimizing system performance, improving resource utilization, and ensuring the reliable operation of your Linux system. By mastering these aspects of CPU management in Linux, you will be well on your way to ensuring a smooth and efficient system. Remember, knowledge is power, and with power comes great responsibility.